Cool. So good evening, everyone. So excited to be here. Let me introduce myself before we start. Let's use the old way. Just a second, you know what? Okay, let me use the keyboard. So my name is Yoni Goldberg. I'm an independent consultant, Node.js and backend only. This is my focus. I am doing it for 19 years, working with 500 Fortune companies and garage startup, working with teams on polishing their Node.js skills. Testing is my love and passion. I work part of my time big part of my time with customers on testing workshops. And I tend to summarize all the insights that I learn at the fields with customer at my GitHub repo, Node.js best practices. You might have come across this one. It's one of the 10 most shared Node.js repo. I'm really proud at this repo, so I'll be glad if you pay a visit. And one other fact is that I live in Israel, in Haifa, Israel. So what do I do here, 1,000 miles from home? Well, it started with this thing. I was driving my lovely daughter to her daycare, and I had to tell her that I'm going to the United States. I had some testing workshop, and I tell her, sweetie, I'm going for a week. I won't be at home. I bring you chocolate and gift. And she told me, Daddy, it's not fair. Why you only had a chance to see America? Like she pictured America like the perfect place because you always get chocolate from there. So she envisioned probably a place with rainbows and unicorns. And she said, "Why? Me and Mama, we also want to see America." And it really touched my heart. That night, I bought 3 tickets from a family trip in the West Coast. And here we are, all the way from Haifa, having a great time in LA. And I said, let's double the fun. Let's also visit a meetup. And here I am. Cool. Excited to be here. Thank you. Another chance? No? I have to test in production. Okay, so what are we going to speak about today? This is a story of me. A few years ago, start failing all the time with my testing project. Suddenly, things just don't work for me anymore. And I went into a journey of kind of soul searching, of looking for new testing techniques and tools. And I want to share with you both the tools, but also the conclusion, how they inspired the way that I'm now thinking about and planning testing. And one of the things that I noticed during this journey that many other people faced similar situations and challenges like me. So it might be also relevant and valuable to you. So what was wrong? Like a few years ago, as I said, I worked with customers, and suddenly testing didn't work for us anymore. And it was kind of weird because I worked with the best practice model, the testing pyramid. Just curious, who here is familiar with the testing pyramid? Cool. It's a very simplistic model. Basically, that suggests that most of your tests should be done with unit testing. Means the test that test software functions or objects in isolation and fake anything external to the code process, like databases or the DOM if you're on the front-end side. And the lesser part, the smaller proportion of your test should go to more realistic tests, those that include all the relayers, the database, the DOM. And this is a simplistic overview of the testing pyramid. And I was working according to this model, which is a very well-known best practice, and it didn't work out. And I was even wondering, can it be that the model that was invented 15 years ago is still not only relevant, it's the only testing model in 2019 where we have now microservices, cloud, serverless, component-based front-end development. Can it be that a 15 years model will still be relevant and will be our only testing model? So I started to investigate this and see what other people are doing. And I found a lot of Twitter dramas and debates, provocative people like Ruby creators. But I can tell you that as of 2019, I think there is a growing consensus that the testing strategies should be rethinked and evaluated. And I think that many or most of the testing enthusiasts that I see share the same ideas. And what is the reason? What's wrong with the testing pyramid that worked for so many years? So first, unit test, the main pyramid tool, actually doesn't test the real flow that the user is going through. It just tells very small software parts, but not all of them together. And as we all of us know, when you put things together and to integrate them, things not necessarily are working. Yeah? The sum is greater than the part. And not only that, by design, unit tests don't test some very painful and impactful layers, like database, like the DOM. So if you show unit testers this image, they would ask, well, what's wrong, right? All the units are perfectly functioning. And the web is... Yeah, so the web is full of memes about what happens when all unit tests pass, but no integration test. So you see here, the dryer, the dryer and the garbage can, each tested and works perfectly. Together, not sure. Also these doors. I'm sure that the manufacturer ran all of them through great unit tests. But in production, this is actually my favorite one. Because nothing's supposed to be wrong here. Nothing's supposed to be wrong here. Yeah. Yeah. By the way, I have to apologize. The rest of the lecture is not as funny as the first part. Okay. This is the first issue. The second issue is that, okay, one might say, okay, no unit testing. Let's do a lot of integration on end-to-end testing. And this doesn't make sense because one of the key principles of modern architecture, whether you're on the back end with microservice or on the front end with components, is that you want to develop small units, right? Small units in isolation. So you have a small React component or a small backend microservice. But then when you need to test them, you need this whole stack just to run the test. Like you have a small microservice, but then to testing in end-to-end fashion, you have to craft the entire AWS stack with all the infrastructure and so many bolts and nodes to take care of, where you wanted to focus on your small unit. And I think that my main concern with the testing pyramid is that we have such a variety of applications that we develop today. Data pipeline, IoT, UI mashup, so many search application, machine learning. Can it be that one model will fit all type of applications in the world? Just for example, I had a customer this year who developed an IoT, typical IoT system. We had sensors ingesting a lot of data into a BI, into data warehouse, and then some tool querying that data warehouse. And the customer asked me, how do we test that? And I was thinking, okay, let's go with the testing pyramid and write a lot of unit tests, but where exactly do you write unit tests here? There is almost no logic. The integration is almost anything here. So given all of these issues and challenges, I start looking for solutions. And I found many modern testing pyramids, testing models. And I'm running today a shortened version of this talk. We have only 13 minutes. I won't go into each of these models, but I can share with you that there is a trend now of moving from a pyramid into a more like diamond shape, where integration tests, quick integration tests, take most of the testing effort. And there are a lot of great, valuable ideas here in all of these models, but none of them address the concern that I shared with you, that all of them try to fit one model into all type of applications in the world, which doesn't make sense, at least to me. So I kept reading until I found a great blog post that is called, it's work now? Yeah, so happy. I found an amazing blog post, which is called Testing Microservices the Same Way. And it introduced this interesting model that shows you a very rich list of tests spread across a long pipeline, across the entire development pipeline, not only development time, but also deployment time and production time. Like you have things here like security also and monitoring. And I really like two ideas here. The first is that it pushes you to think about not just testing, but reliability. You have to make sure that your production is functioning, that you deliver. So if your code is perfect, but some third-party dependency in production is broken, or your infrastructure does not scale up fast enough, it doesn't, I mean, then it worth nothing. You have to ensure that your software is delivered, not just that your code by itself works. And the second great idea is that it doesn't assume that it can predict what type of testing your unknown application will need. It just tells you, you're developers, you're smart. These are your tools. I provide you with a rich toolbox, and you will suit the right testing types for your own specific problems. If you have a lot of logic, use unit test. If you have a lot of integration problems with third party, do a lot of monitoring stuff. There are a lot of testing for each type of the concerns we face. And I really like these models. I wanted to implement it, but I was looking at it and I was not familiar with all this, with all these tools. So I was looking and asking, what is property-based testing, contract testing, shadow traffic? Like, what are these? So I started to learn and practice, and I want to show you some of the lesser known testing types, some of the interesting ones that I found. So right now, my testing toolbox encompasses only 3 tools once I started. So let's enrich it. Let's, in 20 minutes, take it from 3 to 8 test types in our toolbox. And the first one is a very interesting and powerful testing technique that is called property-based testing. Just curious, who's here familiar with property-based testing? Great. So it aims to address the situations where there are so many types of inputs and so many permutations and input types to your software that is very hard to simulate and predict using traditional testing. And it can make your unit and integration types input much richer and realistic. What do I mean? Let's see an example. So how do we typically test? This is a very simple method. Calculate price offer. It gets a string, integer, then a Boolean, and it's doing all this calculation stuff. So how do we test it typically? We just sample, right? We choose 3 specific values for this type of test. Sometimes we do more, we choose 3 types, 5 types, but we usually just pick some samples. And then the output of the software will look something like this. Now, what's wrong with this? We just chose very specific input samples, but in production, there might be so many types of combinations and permutations of input. Think of it, this function might be much more than just a bunch of if-else. There might be behind this a rules engine, a lot of a lot of other modules help calculating the price. Think of Amazon level of complexity of calculating the price. So much code and components, maybe even machine learning. So many inputs can come here. How do I feel safe just by randomizing 3 types of inputs? So how come property-based testing changes this, improve this situation? Same method, right? Same calculate price offer. And we're now using some library. There are a bunch of libraries I just chose test check. And the first thing, it only requires 3 lines of code. First thing, I just tell it what type of inputs does it require. So there is an integer, there is a Boolean. And then the library will generate for me thousands or even more if I want type of inputs for the function. And will call the functions with all of these inputs. So now the output would look something like this, and much longer. It might be thousands type of permutations of input. So if you felt confidence shipping to production a component only by choosing 3 samples of inputs, think how much more confident you feel if you had thousands of inputs feeding into your unit. Sounds like a free lunch, right? It's like, if I can, with 2 or 3 lines of code, just stretch my code with thousands of permutations, why not? Well, not exactly. Let's see, what happens when we try to use property-based testing in a test case? So here I'm calling my unit under stat, calculate price offer, passing here the generated value, 1,000 of them. And then I'm expecting some specific result. But does someone here spot the problem? Like, how can I try to predict the return, the expectation, if I didn't choose any input? It's any input. What is the result of some input that I'm not aware of? I don't know, some output. So what do we do? So yeah, property-based testing are challenging, but this bug can also be a feature. So let's see how can we make property-based testing useful. The first option, I can use it just to detect failures. Means I run it through my React, my front-end component or my microservice with thousands of legal inputs, and I just ensure that it never crashes. Or if it crashes in a proper way. It means it returns only this, for example, these HTTP values. Or, again, not working. Or this is a very useful thing in the JavaScript area. You just stretch your function with a lot of type of inputs, and you ensure that it returns a value or a valid error object is being thrown. A lot of the time in JavaScript, you will receive some not improper error object or process crash. So you ensure that there is, at least if we crash, at least we do it in a proper way. We can also use it to ensure that there's no DDoS attack. So first option is just ensuring that your software in overall behave under certain health limit. Let me just check the time. Denise, how long? 10 minutes?
A little less than 10 minutes.
A little less than 10 minutes. Okay, then we're good. Great. Now, but we can also, we can do also other more useful thing with property-based testing, and we can sometimes prove the correctness of our function. That's because once we use the traditional techniques, we don't prove anything. We just show that for very specific inputs, it behaves. But what about the others? With property-based testing, we can cover the entire spectrum. And to explain this, let me use some imaginary story. Let's say that you work on the JavaScript V8 team, right? Your code runs in millions, like in probably, I don't know, hundreds of millions of browsers. And one morning you wake up and your team is under attack. Apparently, some Twitter troll just tweeted this. So the JavaScript JavaScript includes function is so slow. It's really slow, and your team sucks. I want to switch back to PHP. Your team lead calls you and asks, we must improve the performance of this method. Let's make a better version, modern algorithms. Okay, you sit down, you code a better version of this function. It works. You think that it is at least much faster. Okay, let's call it includes v2. String includes version 2. Much faster. Great. Now you have to test it. How do you test it? This code is going to be executed over millions of users and browsers. It's going to be stretched with so many input permutations. Can you ship such an infrastructural and important method? Can you test it with 3 samples, 7 samples? I wouldn't feel confident. It's going to be used with so many type of applications. So what can you do? You can use property-based testing. Now I'm showing you some technique that is called the Oracle technique. And I'm doing property-based testing. And I'm calling my method. The new includes, and I'm getting some value. But how do I know that this value is correct? Again, it's just random inputs. So what I can do is use an Oracle, some existing components that tells me if the output is right. And in this case, I can use the previous version of includes just to ensure their correctness, right? We already have a function that can tell you whether for specific input, what should be the specific output. We are just concerned with its performance. So I'm using my old version of the code is the Oracle to tell me whether my new one is doing the right job.
How did you test the previous version?
How did I?
How did you test the previous version?
I'm making an assumption here. It's working for 7 years, more. It's working for 20 years all over the world, and nobody complained. It's yeah. Ironically, I don't think you can get better confident than this. Like 50 million users tested it for 20 years. Yeah. But you're right. Sometimes you're not Google V8 and you don't have that Oracle. So sometimes you have to trust your component which lived half a year only in production. So yeah, it can be more challenging. But. Okay, so this is only one of the ways where you can use property-based testing to prove that your component is ready for production. And just minor note that if you're doing front-end and you want to randomize inputs over the DOM, there is a nice tool called gremlin-js, which just, I don't know even how to call what it does. It just clicks everywhere on the screen, and you can catch all type of bugs if you try to catch browser events, or it just play actions not in the order that you were expecting for. Cool, so next time that you have to get high level of confidence that your component works in a lot of type of inputs, or you expect a rich type of inputs from many type of, other system clients, you have now a new tool in your box. Remember this technique. Let's move to the next one, consumer-driven contracts. And it aims to help with all these familiar scenarios where you have an API, whether you are the creator of the API or the consumer, front-end, as a microservice, and there is always debate about you didn't return the right tab, it's not the right error. Going by the documentation, you should have provided this field. There is uncertainty and disagreement about exactly how the information should should be returned. And consumer-driven contracts aims to make all this handshake between API provider and consumer to be very structured and robust. Let's see how. So I'm exemplifying it using a framework called PACT. It's a framework for contract testing. It has a flavor for every language, JavaScript, of course. And it's doing things in a very counterintuitive and interesting approach. So we have two parties here, right? We have the consumer, can be a microservice or maybe a frontend, and we have the provider, the API creator. So interestingly, the one who's defining the expectation, creating the testing, is the consumer. So at first, for example, the frontend, declare in YAML or JSON file, based on your flavor, exactly how the API should behave. So for example, for this route, under this input, you should provide that output. Come again?
1 minute.
1 minute to end?
Yeah.
Oh, I thought that I'm only after 10 minutes. Okay, this changes a lot of things. Okay, whoa. Yeah, so we won't show 5 test types. It might be more 2 or 3, but anyway. So the consumer is creating the expectation, the test types. It then saves them in a broker. Broker means any external medium where these files are shared. There is also some ready services or Docker containers for this. And then the providers take these expectation files and play them against its own API. So in production time, nothing changes. But the idea is that if you have some misunderstanding of the schemas, the provider will realize them very early. And the consumer will always be on the same page because it's the party who defined the expectation. I'll skip the code examples due to the minor time issues that we have. This is, by the way, how the UI of PACT looks like. So this is the broker. Like if you have an API and you have a lot of consumers, all the time you can see what is the integration status with each one of them. You can see what was the last testing run status. If you see something like this, for example, like this, the third row, you have an integration and testing didn't run for a long time, you can get some early alert that something is probably wrong. Last slide. Okay, yeah, sure. So we have to skip some testing type, but I want at least to share maybe the. First, I'll share with you the slides, and you have them all the examples, and you can Google them. But I think just the takeaway, it's fine. 1 minute takeaway. Thank you. I think that my personal takeaway from all this journey of learning about a lot of new testing tools and stuff was that if I start now a new project, and if I want to stick to some model, it probably looks more like a diamond type of things, more integration testing. But I also try now not to stick to models because the type and amount of concerns that you have to address these days in production, in deployment, security, so much stuff. No model cover all this type of testing and reliability mechanisms that you have to apply. So I just become familiar with a lot of reliability tools, testing tiles, and I just match the right tools for the problems that I have for every specific application that I faced. Just saying, thank you. It was my pleasure. Thank you very much.